Welcome to WaterSim. This presentation will give you some basic background on the purpose for utilizing the WaterSim model. This model was developed by Decision Center for a Desert City. To learn more about us, please visit our website at dcdc.asu.edu. Support for education outreach related to WaterSim has been made possible by a grant from the Ellis Center for Education Excellence of the Arizona Community Foundation. We begin our exploration of Arizona's complex water system by taking a look at global water. The WaterSim model and curriculum focus on sustainability and emphasize sustainability of water resources. We define water sustainability as the ability to manage water to meet the needs of the present social, economic, and environmental systems without impairing the ability of future generations to do the same. We've focused on water resources here, but there's a couple of key terms to highlight. First, we're talking about long-term. We're not talking about next year. We're talking about 50 to 100 years. Second, though there are many aspects of water sustainability, we are focused on when water supply and water demand are balanced. This is critical to human settlement because when demand exceeds supply, human settlements fail. When thinking about water sustainability, we are looking at the long-term balance between water supply and water demand. Unfortunately, planning for water sustainability is difficult for several reasons. The systems that support water supply and demand are highly complex and dynamic, making it difficult to fully understand how they work and interact with other issues. The future of water supplies and demand is not easy to forecast and is fraught with factors of high uncertainty, like human behavior and the climate. People use water in different ways, and their views of what constitutes sustainable water use differ. This does not mean that one viewpoint is wrong and another is right. They're just different. Because of the complexity of water systems and the uncertainty about the future and the differing viewpoints, it's not possible to manage water to optimize everyone's viewpoints. There will be a need for trade-offs. Water sustainability can be considered at a variety of geographic scales, from global to local to the individual. At the global scale, while there is a lot of water in general, the fresh water we need to survive is not so abundant. Only about 3% of the world's water is considered fresh water. Water we need to survive has to be accessible to us, and if we look at global fresh water, almost 70% is found within glaciers and the ice caps, not readily available to us to consume. Most of the global water not found as ice is located underground, available to us only if we can dig or drill a well to get to it. Only just over 1% of the global fresh water can be found on the surface, where we can more easily get access to it. Finally, most of this surface fresh water, 70%, is found as ice and snow most of the year, and we have to wait until it melts and it flows into rivers and lakes, so we're able to use it. On a global scale, accessible fresh water represents a very small fraction of the total water on the planet. Circulation of water around the planet is driven by climate, but we're not able to predict weather patterns over long periods of time. We have climate change models, also known as general circulation models. but it's just too difficult for us to predict more than 1 or 2 years out. We're pretty good at predicting temperature through GCMs, but predicting precipitation over long periods of time induces much more uncertainty. We use climate models to try to estimate what's going to happen to weather and climate conditions over very long periods of time. And this figure illustrates a summary of many models, 21, that attempt to estimate what's going to happen across North America in the long term with precipitation. The dark brown areas are where precipitation is going to be less than it has been in the past. The dark green areas are where it's going to be more than it was in the past. So climate change for some places is going to generate a lot more water, and in other areas it's going to be drier. Water is used in many ways. One way to classify this use is water used for agriculture, domestic use, which would include water used in cities, and industrial use, such as mining. On a global scale, more water is used for agricultural use than all other uses combined. Domestic use is close to 1/3 of that used for agriculture, and industrial water is close to half that of domestic use. There are distinct geographic patterns of water use, with water use not the same in different parts of the world. Agricultural water use is concentrated in the mid and southern areas of the world, with it generally being higher in developing countries than industrialized countries. Industrial water use is the opposite, with concentrations more in the northern sections of the world, with more industrialized countries than developing countries. Domestic water use has some unusual global patterns. Domestic water use seems generally higher in developing countries than developed countries, though there are notable exceptions in Europe. Water use seems higher in mid-northern and southern sections of the world, though there are exceptions to this as well. Sustainable water means a long-term balance between water supply and water demands, but we've shown at a global scale this is not as simple as it sounds. There's a great deal of complexity within the system and uncertainty about the future. We have a model that is probably one of the most sophisticated urban mass balance models in the world. It computationally models regions' rivers and reservoirs and regional groundwater supply, as well as the demand balance for a selected region. It was built through a significant amount of research and continues to serve researchers. You are able to run that model through our web interface called WaterSim. Trainings are available for operating this complex model through the interface. Water supply, availability, and demand, use, need to be managed to provide enough water to maintain a sustainable region. This includes water for agricultural production, riverine habitats, human health and comfort, and economic opportunity. If more water is used than is present in existing ground and surface water reserves, then the system is unsustainable. Different stakeholders can have vastly different perspectives on water management. The WaterSim interface can be used from different perspectives. Depending on your perspective, you are more or less likely to make different water policy choices available in the interface. With the goal of managing the water supply until 2050, the model can be used to simulate the outcomes of various policy choices.